Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Postgraduate Diploma in Computer Applications, PGDCA, New, Semester 2, MCS to 07 Database Management Systems, Block-2 Database Normalization and Database Query, Unit-7 Structured Query Language, 7.0 Introduction. As discussed in the previous units, a relational database system consists of relations which are normalized to minimize redundancy. The normalization process involves the concepts of functional dependency, FD, multi-valued dependency, MVD, and joint dependency, JD. The normalization results in the decomposition of tables into smaller but non-redundant relations. After designing the normalized database system, you would like to implement it by using software called Relational Database Management System, RDBMS. RDBMSs were designed to manage relational data. Some of these RDBMSs are Oracle, DB2, SQL Server, MySQL, etc. All these RDBMSs are designed and developed by different organizations and use different data storage formats. A structured query language, SQL, is one of the standards which was created for the transfer of information from a RDBMS. The SQL consists of three basic languages, viz. Data Definition Language, DDL, which is used for defining the structure of the relations in the form of SQL tables and indexes, Data Manipulation Language, which is used for input, modification and deletion of information in SQL tables, and Data Control Language, which is used for controlling the access rights on the data of SQL tables and indexes. This unit introduces these three languages and the basic set of commands used in SQL. You must learn SQL to use database technologies, therefore, you are advised to go through this unit very carefully. You must practice the concepts learnt in this unit on a commercial RDBMS. 7.1 Objectives. After going through this unit, you should be able to times create SQL objects, tables, indexes, etc. from a database schema, times insert data into database tables using SQL commands, times retrieve data from a database using SQL queries, times use the group by and having clauses of SQL, times using aggregate functions of SQL, times create access rights on different database objects using SQL. 7.2 Introduction to SQL. The structured query language, SQL, was initially designed at IBM by D.D. Chamberlain and R.F. Boyce for the relational model that was proposed in 1970 by E.F. Codd. SQL was designed as a fourth-generation programming language to produce multiple record output as a result of a single command. In addition, SQL commands did not require the specification of indexes or other information for data retrieval. Later, SQL was standardized by the American National Standard Institute, ANSI, and a number of standards of SQL have been created, starting from SQL 86, which was proposed in 1986, SQL 92, SQL 99 and SQL 2003. Several modifications have been proposed in SQL 2003 in the years 2006 to 2019. One of the key advantages of using SQL is that it is a query language of most RDBMSs. Thus, it facilitates the migration of a database from one RDBMS to another RDBMS. However, some differences can be found in the SQL implementation on several RDBMSs. This unit covers some of the basic features of SQL only. Why did SQL become popular? One of the major reasons for SQL's popularity is that it allows you to write queries without specifying how the query would be executed. For example, in case you want to join three relations or tables, say A, B, C, Then SQL allows you to join these tables without specifying the sequence of joining. The decision about how to execute the joins, e.g., A join B, join C or A join B join C, what indexes and views are to be used, etc., are left to the query parser, translator, and query optimizer of RDBMS. In addition, the syntax of SQL is closer to the English language. Thus, SQL queries are simpler to write and run. The following are the features of SQL in the context of RDBMS. Times SQL is non-procedural. As in SQL, you just need to say what information is required by you and not how that information is to be acquired from the database. Times the syntax of SQL is closer to the English language. Thus, it is very easy to comprehend. Times in general, the output of a SQL query may be a single record or a group of records. Times an interesting feature of SQL is that it can be used at different levels of ANSI's three-level architecture of database system. SQL includes the following three sublanguages. Times data definition language, DDL. The basic focus of DDL is the commands that can be used to convert database schema into SQL tables, indexes, etc., or change of structure of the tables. These commands also allow you to define the constraints on the attributes of a table. The DDL commands are explained in the next section. Times data manipulation language, DML. The purpose of data manipulation is twofold. First, it has commands to input, modify and delete the data in the SQL tables. Second, it has a select command, which helps in the retrieval of data from one or multiple tables. Times data control language, DCL. The purpose of these commands is to specify users' privileges to database users. These commands are very important in client-server databases with different types of users. 7.3 Data definition language. The design of a database consists of the physical, conceptual, and external schema. To implement this design, you need to define these schemas using SQL. In this unit, we use commands to define the conceptual schema. The external schema-related commands are discussed in the next unit. As far as the physical schema is concerned, we will cover only a few commands. The conceptual schema, which includes the relational schema and attributes, is implemented in RDBMS as a set of tables and columns, whereas the tuples of the relations are implemented with the help of rows or data records. We will explain some of the basic DDL commands in this section with the help of an example. Consider the relations of a university database system, namely student and program. The student relation, student, has the following data: student ID, STID, which is also the primary key, the name of the student, SNAME, the program code in which that student is registered, PROCode, and the mobile phone number of the student, STMobile. Please note that this schema assumes that a student is allowed to register in only a single program for which he is allotted a unique student ID. The second relation, program, has the following data: program code, PROCode, which is also the primary key, the name of the program, PROGNAME, and the fee for that program, student, STID, SNAME, PROCode, STMobile, and program, PROCode, PROGNAME, fee. The first step would be to define the data types of various attributes. We propose to use the following data types for the attributes: relation name student, attribute STID, SNAME, PROCode, STMobile, data type character number, length 446 12 digits. You may refer to the information manual of that DBMS. You may select one of these data types for each column. Char n. It accepts a character string of size n. The character string can include alphabets, numeric digits, and special characters. The size of each string is fixed, that is, n. Varchar n. It accepts a character string up to the size n. The character string can include alphabets, numeric digits, and special characters. Boolean it accepts the value false, 0 value, or true, non-zero value, integer, n. It can store signed integers or unsigned integers of length 32 bits. N represents the display width of the integer, decimal, n, d. It can store decimal numbers of size n having d digits after the decimal point. The default value of d is 0. Date represents a valid date. It uses 4 digits for years and 2 digits each for month and day. Timestamp it assigns a timestamp, which can be used to determine the recency of data. Figure 2. Some basic data types. For the relations of Figure 1, you may select char for std, procode, stmobile, as it is not required for computation, and varchar for stname and progname, as the names of students may be of different lengths, so are the names of the programs. The data type of phi is decimal, 5, dot, creating the database and the tables. In order to create the tables as given in Figure 1, you need to first create a database using the following command. Create database. Use this command is needed when the DBMS has multiple databases. The following commands will create the university database. Create database university. Use university. Now, you can create the tables using the create table command. The following is the syntax of this command. Create table, column name 1, constraints, comma, column name 2, constraints, comma. The following are the descriptions of the create table command. Times the name of a table should begin with an alphabet. It should not contain blank space and special characters except the underscore character, underscore, dot. Times you should not use reserved words as a name of a table. Times you should use a unique name for each column in a table. Times the constraints are optional and therefore shown in brackets. Times the data type should include the size of the column. Times you may use any of the following constraints on the column. Not null. This column of a table cannot be left blank while data entry or modification. Unique. This value should be unique across all the values in this column. Primary key. The column is or is a part of the primary key. Check it is followed by certain conditions, which should be fulfilled by the column. Default. When a default value is specified for a column. References. This is used for specifying referential constraints while creating a table. Figure 3. Some of the constraints in create table command. Now, you are ready to create the tables. Since the table student contains a reference to program table, therefore, you may create the program table first using the following command. Create table program, procode char, 6, primary key, progname varchar, 30, not null, phi decimal, 5, comma, check, phi 1000 and phi 100. The purpose of this subquery will be clear after you go through the next subsection. The subquery will find those programs which have more than 100 students. Deleting data. You can use the following command to delete one or more records from a table. Delete from where. The delete command may delete one or more data records at a time. For example, you can try deleting the data of the PGDCA program from your database using the following command. Delete from program, where procode is equal to PGDCA. However, as there exists a foreign key constraint with referential action restrict and you have already inserted a student who has PGDCA as his program, therefore, DBMS will not allow you to delete the program PGDCA from the program table. In case you want to do so, you need to first delete records of all the students of PGDCA from the student table and then you can delete the PGDCA program from the program table. Please note that you can use subqueries instead of conditional statement in deletion also. 7.4.2 Data retrieval. One of the most popular features of any DBMS is the ad hoc query facility, which requires data retrieval as per the need and access rights of the user. Select statement is one of the most used statements of DML, as it helps in the retrieval of requisite data. In this section, we discuss various clauses of this statement. Select statement. The following is the basic format of the select statement. select, from, where. The following are examples of the use of this statement for the retrieval of data from the two relations given in Figure 1. Example 1. List the details of all the programs of the university for answering this query. PGDCA 123. Create user PGDCA_student identified by PGDCA 123. Use of grant command. Grant is used to give different kinds of accesses to a database user. Block 3 covers the basic aspects of the grant option. In general, SQL supports two kinds of access permissions, times the permissions that are at the system level, times the permissions at the level of an object, such as a table, record, column, etc. The system-level permissions are, in general, specific to the DBMS environment. Therefore, you may refer to the system documentation for details on such permissions. In this section, we provide a basic introduction to object-level permissions with the help of examples to give permission to get information from a table. The following SQL command may be used: grant select on student, program to PGDCA_student, to give permission for inserting and updating a record in the student table. You may use the following SQL command: grant insert, update on student to PGDCA_student. In case you want to grant the select access rights to more than one user on student table, then you may use the following command: grant select on student to PGDC_student1, PGDC_student2. Use of revoke command. The revoke command is used to remove the access permissions that were granted to a user. For example, you can also revoke select permission using the following command: revoke select on student from PGDC_student. The following command will revoke all permissions of a user on student table. Revoke all on student from PGDC_student. Use of drop command. You can remove a user using the drop command. For example, you can drop PGDC_student using the following SQL command: drop user PGDC_student. 7.7 Summary. SQL is one of the most important languages for any RDBMS. It allows a user to create tables, insert and update data in the tables and retrieve information from the tables. In addition, data of a table can be made available to only authorized users. This unit first introduces you to basic aspects of SQL and thereafter discusses the DDL commands. It is important that while creating tables you also include the constraints that are to be fulfilled by the tables. The constraints in SQL may be implemented using check clause, primary key clause, foreign key clause, etc. You must also implement the referential action in case of referential integrity. You can also alter the tables if needed. This unit discusses the DDL commands for all the above operations. After creating the table using the DDL commands, next you use the DML commands to insert data into the tables. In case of any changes in the data values in the table, you may use the update command of DML. The commands for data insertion and updating have been discussed in the unit. One of the most important DML commands is select, which allows the retrieval of data from the table based on various criteria. This unit discusses various clauses of select statement, viz., select, from, where, group by, having an order by clauses. Finally, the unit discusses the create user, grant, revoke and drop commands of DCL. You may please note that this unit does not cover all the SQL commands. You must practice these commands and learn more SQL commands from the user documentation of DBMS that you may use. Thank you for watching. We will see you in the next video with the next chapter.